morning. Should we start? The exam period is clearly ongoing. Okay, so today I'll cover a module in Python called Pandas. And it's basically a tool which you can use to do data analysis. And so in particular, it can be used for the assignment 6. Well, you can solve the assignment 6 without Pandas, but you will see that it might be useful to use this tool. Okay, and so what is Pandas? Basically, Pandas is a high-performance data analysis tool. And you can use it you typically use it for 4 main things. You use it to load in data that you get in various different formats. So you might get it as a comma-separated file. You might get it as an Excel sheet or, yeah. Then you can prepare that data. So data is often very noisy, so you have fields that are empty, that are fields that are kind of messed up in some way, so you need to clean data. Maybe you have the data distributed over multiple files, so you want to merge the data. You want to select parts of the data that is actually of interest, and so Pandas gives you the tools to do that. And then you want to analyze the data, right? So you want to extract information that you're interested in. So for example, you want to plot the data, you want to print parts of it, compute some indicators, maybe the maximum, the minimum, the mean, or some statistical values of it. So again, Pandas gives you some tools, at least some basic tools to do that. And then also you can use Pandas to output the data again. So maybe you want to print it as an HTML file, as a PDF file, or again, a comma-separated file. Okay. So, okay, installation. If you have Anaconda, if you have the Anaconda distribution, then it's already installed, so you don't have to do anything. If you have Miniconda, then you install it with a conda command. So you just type in conda install pandas, and it installs all the dependencies for you. And if you have any other distribution, Python distribution, then you type in pip install pandas -- user, or you might have to type in pip3 to get the Python 3 version. Okay, so there's loads of information online. So in particular, what I find very useful is this Pandas cookbook. So this is a bunch of IPython notebooks that you can kind of go through, and it explains Pandas on various different examples. Then there's also the official Pandas documentation that you can go online, and there's a book that you can also order if you're more interested. This book actually covers not just Pandas, but NumPy and all the different tools that you might also want to use for data analysis. Okay, so let's get started. The first thing that we need to do in order to use Pandas is to import it. So the first line here, matplotlib inline, is actually just a command for IPython to tell IPython that when I produce plots, they should show up in the notebook rather than in a separate window. Then here on the next line, I import Pandas. And I'm not sure if I've explained this syntax before. So I use import pandas spd. And so this last spd here just creates an alias for the module name. So in future, I can just write in pd dot and then a function name or class name rather than pandas dot. And so this is useful often because it saves some typing. So also I import numpy as just np rather than instead of having to type in numpy all the time, I can just type in np. And it's also useful if you have modules with the same names. Imagine it's easy to create 2 modules with the same name, right? And then you would have a naming conflict. And so in this case, you can also use this syntax here by just renaming them when you import the 2 modules so that you can differentiate them. And then I also import the matplotlib pyplot module here. Again, I rename it. And I set 2 options here. This changes kind of the default matplotlib style to make it a little bit prettier, and then also the standard figure size, just to fit them on my Python notebook. Okay, so that's all we need to get started. And so the next thing we need is some interesting data, right? So we want to do some real world stuff, so we need to get data from somewhere. And the nice thing is there's actually loads of data out there that you can use, and really interesting data. So I've selected some Norwegian data sources that might be interesting. So first of all, there's the Statistics Sentralbyrå, so this is ssb.no, so that kind of produces various different statistics or collects statistical data about Norway. And most of the data is online, so you can just download them in a different format, and you could start analyzing them with Pandas. So for example, the population in Norway and the average income and so on. Then basically all of the big services in Norway have an API. An API stands for Application Programming Interface. And it's basically just a programmatic way of getting information about that service. So for example, if you were interested in, maybe you're interested in buying a house, and you would like to do some data analysis on the house prices in Norway, and kind of maybe figure out where in Oslo is the best, has the most potential, right, to increase maybe in house prices. So what you could do is you could kind of use the Fin API, download all the house price information of the last years. Maybe you get them distributed in different areas in Oslo, and then use Pandas to do some data analysis. Then there's the router API, so that you can actually use to get real-time information about all the buses and the positions and when they come and where they go and so on. Then Ur, so here you can actually get loads of data about weather forecasts. So this might be also interesting. So today in the lecture, we are actually going to use the Oslo Bycykel API. So that's, here you can get information about all the bike stations. So you all know the Oslo Bycykel, right? Yeah. So there are these shared bicycles that are actually, I really like them. I like using them. And so with this API, it gives you information about which stations are free at the moment, which stations are there, how many bikes are logged in, how many available spaces are there. And also you can get usage information. So you can download kind of how many people used the Bycykel over the last month. And then if you're more interested in financial stuff, there's a website called quantal.com. There you get loads of financial and economic data that you can download and do some data analysis. Okay, but so we want to use the Oslo Bycykel data. So when we go to this developer.oslobycycle.data, let's just do that. So then we end up on this page, and you can see we can get, so what I'm interested in is this trip data. I want to see, I kind of want to get information about how people travel with the bicycle, Oslo Bycycle. And you can see there are two formats, the JSON and the CVS format. So I just clicked on CSV to download the data as a CSV format. Okay, so now we need to understand how we can read in CSV data. So Pandas comes actually with, let's see, why is this not working? Ah, here we go. Restart my kernel. Interesting. 1 second. This seems to be crashed. Let's open this again. Oh dear. Oh, here we go. Why is this not? Right, that makes perfect sense. I should import Pandas before we can get some information about it. Okay, so sorry about this. I need to remember to actually execute all the cells, otherwise the slides won't make sense. Okay, so now we can see, so Pandas offers various ways how we can import data, and I just kind of, they all start with the name read. So I just down here, I just list all the different functions that we have to read in data, and you can see there's probably 20 of them. And you can read from Excel, from CSV, even from HTML, JSON, even from clipboard. Yeah, but so we're interested in this read CSV because we've downloaded the data as CSV. So that's the function we're going to use. You can also, if you just have the data as a NumPy array, like here, just create a NumPy array with random data. You can also load in the data like I've written down here. So you just create a new pd.data frame and you pass in the array. Here, this is an 8 times 4 large array, and so I can also give the columns names, which I've done here. So just as a side note. Okay, so I've downloaded all the musical data. I've downloaded them for 4 different months. You can always see the name is 2016 10/31, so this is the October information. Oh dear. Then we have September and August. And you can see this is quite large. So it's 14 megabyte, 21 megabyte, and 22 megabyte of data for each month. So we expect to see quite a lot of stuff in there. And we can actually, I use the bash command head. Head just shows the first, I think, 10 lines of text in a file, just prints it out to standard out. And so if we look at the first lines of the October data, you can see, so this is the raw data that we downloaded. So we can see we always get some kind of starts. So that the first line is a header line, start station, start time, end station, end time. And then we always have a comma separate. So here, this is the first column. There's a comma, then there's a second column here, a third column, and then the final column down here on the right-hand side. So the important thing that we need to learn here is that this is a comma-separated file, and we can now use the pd.readCSV function, and we pass in the file name. So I just type in the file name in here, and I use this sep argument here to just tell Pandas that we're talking about a file that is where each column is separated by a comma. And so I can execute this, and you can see the object that I get back, the spike stats, is a data frame. So a Pandas data frame is kind of the fundamental data type that we're working on when we work with this, when we're doing data analysis. And so I can also just print out this data, and you can see now it's basically exactly the data that we've seen before, just much, much nicer formatted. We have the number of start stations here, the end stations here, and then start time and end time. And so basically the way I have to read this data is that each row is one trip, okay? And so the one person has started a trip at 6 o'clock and 8 seconds after, 8 seconds after 6 o'clock from station with the identifier 283, and stopped his trip at, well, roughly 1.5 minutes later at station 138, right? So the first thing that we can see is apparently the Oslo bike stations open at 6 o'clock because there was nothing before. So that's, yeah, and then there's loads and loads of data. So we can see it actually just because we don't want to print it out, we can see we already at 242,000 trips. And in total, it tells us down here, we have 758 rows or trips in that data in just 1 month. You can also see that if we go to the top again, that Pandas automatically used the first row in our CSV data as the column titles. So we didn't have to worry about that. It detected it automatically. Also, we can see here on the left-hand side, Pandas created an index for us. So each row now has a unique identifier that is called the index. So we can access each row using this unique index here. Okay. We can also see how we can change this index later on. Sometimes you don't want to use the automatically generated one, but one maybe more meaningful one. So one thing that we will use a lot is this. We don't always want to see all the data. So it's really useful to just look at the first 5 rows of the data. And there's a convenient function called .head. So you just call this bike stats. This is our data frame, and we can just call .head, and it will list us the first 5 items. So this will be really convenient to just inspect what we're doing. Okay, so the first thing that we might be interested in is we might want to select certain columns of interest. And the way you do that is just with the normal standard Python indexing. So you use this square bracket notation, and in this square bracket, you type in the column name that you're interested in. So if I'm interested in the start time, I can index the start time, and then I can extract the first few items with the head. And you can see, yeah, this is the first items that we get. Then what else can we do? We can select multiple columns by just using the same indexing notation, but now passing in a list of column titles. And so if I do that, then I get basically a new data frame out that now only consists of these two columns that I'm interested in. So as we can see, the first trips always start at 6. So maybe we're interested in when does the bicycle station closes. So instead of using the head function, I can use the tail function to list me the last few items in a row. And I can also provide an integer to just specify how many of the last rows I want to see. And so if I use tail 3, then it shows me the last 3 rows, and I can see from the times 23, 59, 10 seconds, so 50 seconds before midnight. So apparently the bike stations close at 12 o'clock. All right, so one thing that isn't quite right, one thing that Pandas didn't quite do right is the detecting these dates. So these are actually dates, but currently, if we look, we can ask Pandas to print out the types that it detected, and we will see that it didn't quite get the dates correctly. So for the column start station, it detected an int64, so that makes perfect sense. The start stations are always integers. Then the start time, so here it just detected an object, but really we would like to tell Pandas that this is a date, because later on we want to do some time computations, which we can only do if Pandas passes this correctly. So end station here, this is interesting. End station is a float 64, even though we expected it to be an int also. I explain this in a second why this is. And then the end time, this should be a date again, but it isn't, so we need to fix that. So we need to have a way on specifying types of columns. And the way we do that is when we read in the data with read._csv, we have the separator argument, but we can also specify a list of columns that we expect to be dates. So this argument is called parse_dates. It takes in a list of columns, column titles, and for all these columns, Pandas will try and parse the columns as a date object. So if I read in this data again, now my new variable, I call it bakestats types, because it's now hopefully with the correct types. So you can see I just started it. It just finished now. So it took quite a bit longer now, because basically for each row, Python will have to call the parsing of the date. this is our updated table, and you can see if we can compare this, it looks slightly different. So it's not, if you print it out, actually the difference is quite minor. But one of the main differences is that here we had the time zone in here, and this is now removed and incorporated into the time. So this is actually now shown in GMT time. So the bike station now opens up at 4 o'clock at GMT time. But so this already tells us that Pandas did something sensible here because it did an internal conversion. And we can also now check if the type is indeed a date time. So what we can do is we can extract the start time column and call the .dtype attribute. And this will give us the data type for that specific column. And then we just compare it with the NumPy data type datetime 64 to see if they're equivalent. And the result is true. So indeed, our start time column is now a datetime data tape. So the last thing that that's still quite confusing now is the start time. These are correctly identified as integers. But the end stations, these are floats. And the reason why Pandas decided to use floats is because it turns out that in the end station columns, they're actually empty values or not a number values. And so the integer data type doesn't have a not a number. So instead, Pandas chooses to use the closest data type that has a not a number object, and that these are floats. So that's why the end station here are floats. And so the reason is because for some trips, someone took the bike and never returned it. Right? That's when these rows occur. But every single trip will have a start station. Well, yeah, I guess so. I guess only if you buy new bikes, right? Then you might plug in a new bike, but that's not really a trip. Okay. The next thing is we would like to plot stuff. So Pandas offers a convenient function called plot that we can call on a data frame, and it will plot the data frame for us. So for example, if I'm interested in plotting the start stations as a bar plot, I extract the relevant column that I'm interested in, extract the first 5 rows using the head function, and then call the plot function with the argument kind equals bar to produce the plot. And so the way you need to read this plot now is it's a bit cryptic still, but basically each bar here corresponds to one trip, and on the y-axis we have the identifier of the bike station. So it's not too meaningful, but basically, so the first trip started at bike station, what is that? Maybe 283 or something, right? Well, the second trip started on this bike station, yeah. So if I wanted to have more here, if I wanted to show more here, maybe the first 50, I just change this. I just add this attribute 50 here, and then I get the starting stations for the first 50 trips. So what about the labeling? So the x-axis here is automatically labeled with the index of each row. So remember these indices, these were automatically generated, starting from 0, going to 240,000 or something like that. And so here on the x-axis, it's these labels here, they're basically the index of each row. And on the the y-axis, we have the value of the station. So the station IDs, these were integers, so that's why on the y-axis we see integers as well. So we can also produce different kind of plots. So if we open up the man page for plot, you can see here's an entire list of plots. So you can produce line plots, bar plots, histograms, various different ways and various different options that you can choose from. You can also plot multiple columns at the same time. So if I extract two columns now, the start station and the end station, I extract if I extract the first 5 rows and then plot this thing as a bar plot, you can see that now I get 2 bars for each trip, namely the start station and the end station, colored in different ways, and yeah, otherwise it works the same way. What else can we do? We can label the x-axis. So I mean, this is basically just the same stuff that you have in NumPy. So you have these options. The x. Oh yeah, sorry. So here what I'm doing is I'm changing so rather than having the index for the x-axis, I want to use the start time in the x-axis, because each trip has a start time. So rather than seeing here 0, 1, 2, and 3, I want to see when this trip started. So I can do that as well. And then here you can see now on the y-axis it's very small, but here on the x-axis these are now actually dates. So now I know when these trips here always started. So then we can use a scatter plot so a scatter plot is basically an XY plot with, in this case, what I'm interested in is from where to where do people travel, right? So what I can do is I can create a scatter plot where on the x-axis I have the starting station ID, and on the y-axis I have this stopping station ID. And when there's a dot somewhere, I know there was a trip from this starting ID to this ending ID. And if there's no dot, then nobody traveled from this ID to that ID. So let's do that. So this now actually produces a plot for all trips in October, I think. So you'll see it takes quite some time. And yeah, we get quite a lot of dots. So these are 24,000 dots. And so you can see basically people traveled from almost everywhere to almost everywhere. It's almost a dense plot. There's some areas, so clearly some station IDs haven't been used. So there's some kind of empty rows here. They haven't been. Well, that's interesting. So 1 second. So if there's an empty column here, if this station didn't exist, I would also expect an empty row, which I maybe they're actually there, and it's just difficult to see because the aspect ratio is quite different. Yeah, I think there are actually empty rows here. They're just very difficult to see. But so you can see there's some kind of, let's say there's an empty dot up here, right? So someone never traveled from station 320 to station 300. Yeah, 300. Yeah, whatever that is, 325 or something like that. Yeah. Yeah. So this is how you can, just by visualizing the data, one can kind of get an overview on what's going on. So the next thing we can do is we can plot it as an histogram. And so that will plot us on how often a certain value is showing up in the data. And so, for example, if we create a histogram with the starting station, we can see how many trips started with that specific station. So in other words, we can find out which stations are the most busiest ones. So let's do that. And here we go. So there's something not so nice about this plot in that histogram kind of lumps together multiple stations at once. So in some way, this plot isn't so meaningful, but you can see at least kind of this range of stations between 210 and, 180 and 200 is kind of quite busy, while maybe the stations up here in the range of 300, they're less busy. But really to kind of boil it down to a specific station, one would need to refine that plot here. Okay, any questions so far? It's not too difficult, right? But then we can save data again. So the same way we can read loads of data in, you can also save the data. And if you look through the list here, there's actually a lot of things that you can do. You can save it as HTML, even as LaTeX, which is quite interesting. So let's just save it as CSV again. So I just call bikestats to CSV and then the file name. Let's try the LaTeX one. So I save the table as a LaTeX file, just the header of the table, otherwise we get a massive file. And if you print it out, so this is a Python table, a LaTeX table, so we could just kind of copy and paste this into our LaTeX document to compile it. We can also print it out to HTML and open the file. And so then I just opened a new website with that data. So now it created a nice HTML table for us. We can also convert it as a NumPy array. So there's this function called sMatrix. And when you call that, then you get the table as a normal NumPy array, and you can do all the things that you know from NumPy. Okay, so I've explained to you a little bit more about selecting data. So I've already shown you how you can select data using the column names. So you just use the index notation. You can, just as we used from NumPy, we can also select rows, so not columns but rows, using the slicing notation. So if you just use the square brackets and then some index range, so for example 5 to 10, then we get the 5th to 10th, or 5th to 9th, is always excluding the last one, 5th to 9th row of that data frame. And then also, as we used to in NumPy, we can have a third argument to the slice that introduces a padding. So if you're interested in row 5 to 50, but only every 5th row, so this is the syntax that I would then use. And so now you can see I get row 5, 10, 15, 20, and so on. And then obviously you can combine them. So you can write bikestats start time. So I mentioned the start time column, and then row 5 to 15. And then you get that information. So interestingly, you can actually swap the two. So it doesn't matter if you first extract the row and then the column, or first the rows and if you first extract the column and then the rows, is equivalent to first extracting the rows and then the column. Right? You get the same information. Okay, so let's try and do some fun stuff with that data. So let's find out what are the top 10 bike stations in Oslo. And the way we do that is, so basically we have to go through all the trips in the data, and we have to look at the start station, and we have to count how often does each start station occur in that data, and add it up. And then we show the most. Then we show the stations with the highest count. And this is a convenient function for us that does this automatically. So there's this function called value counts. It just counts how often does each value occur in that column. So all we need to do is we take our bike data, we extract the start station column, and we call value counts on it, and then we extract the top 10 rows of that. So let's do that, and we can see, so this is still quite cryptic. So what we get is kind of the station number 233 was used 7,832 times. Right? And then it kind of goes down. We can plot this to make it a little bit more interesting. So now I'm doing exactly the same, but I'm extracting the first top 100 stations, and I plot this entire thing as a bar plot. That's what you get. So now you can kind of see the distribution and how people use the bike station. So clearly there are kind of 3 bike stations that are used almost twice as much as the other ones. And then it slowly goes down. And then it's a huge bunch of bike stations that are used quite frequently. can also try and kind of find out what is the least bike stations. So then I want to show the data I want to start from the bottom, so I show the last minus 10 data points all the way to the end. So this is how I show the last one. So you can see the bike station that was used the least was bike station 256. It was used 153 times. Okay. So it'll be, so all this was quite anonymous still. So it would be really useful if we could, so all these station IDs, right, that's not very useful. We need to know what they actually mean. So what we need is we need to find information about each station. We need to have, for each station ID, we need to understand how, where is the station, and so on. And so conveniently, Oslo Bicycle has an API where you can download all the stations and all the information about all the stations. So I've done this, and I've downloaded as a JSON object, just stored it in this data bicycle stations. So I just used this little tool, command line tool, python -m JSON.tool, to just visualize that JSON data. And so now you can see this is a huge file, so I can, for all the stations. But maybe let's just have a look at a single station so that we understand what the data is. So this JSON object has it's basically almost like a Python dictionary, the way you should read it. And so basically, it has just this stations list. So it's a dictionary that contains a stations object, and that's a list of all the stations that we have. And so for each station, we have the ID. So hopefully, this will be the ID that is also used in the data frame that we used before. Then we get information about is it in service at the moment, true or false. Then it has a title. So this will be roughly in which area the station is. It also has a subtitle. So here, Mellom Nordbygata or Utegata. So here it tells us more specifically where the station is. We can extract how many number of locks the station has. And then, this is interesting. So here we actually get the center of that station. So we get the latitude and the longitude position of that station as data. And then also some kind of bounds that maybe a larger area for that station. Then if you go a bit lower down, here the next station starts. So this is now station 158. So that looks like it's the data that we're looking for, right? So the obvious thing now to read in this data is to use this function pd.readJSON. It's just the same way we read in the CSV. So unfortunately, that doesn't work. And the reason why it doesn't work is because Pandas expects the JSON data to be in a kind of Pandas-specific format. So yeah, so that's not something that we can use. Instead, what we'll need to do is we need to load in the JSON data manually first, extract kind of the relevant parts that we're interested in, and then read it in Pandas. So the way we do that is I imported this JSON module here. That's just a module for loading in data in Python. And then I call JSON.load with a file. So here I open up the stations.json file in reading mode. So you remember how you open files, you can specify if you want to write, append, or read the file. See, I'm just interested in reading it. And so, yeah, let's do that. So if I load in the data, this is exactly what we had before, what we've shown before, but now actually as a Python dictionary. So we have a dictionary, and the first key here is the stations key that contains the list of all the stations that we have. So then, because I'm not interested in, so the first thing I can do is I'm only interested in this list of stations, right? So I can kind of remove the outer dictionary part. So what I do is I just type in JSON equals JSON stations, and then extract the stations key. And so now, exactly, so now I just have a list of all the stations. So that's exactly what I wanted. And now, with that, Pandas actually has an option to to load in a JSON, but it's not the obvious read JSON function. It's actually what you need to call is pandas.io JSON.json normalize the function. And you can pass in this list now. And what that does, it reads almost arbitrary JSON and tries to normalize it into the Pandas format, and then load it in the normal way. So with that JSON normalize function, when we call it, we have what we're looking for. So we have a bunch of identifiers again here on the left. We have the titles, so there's some bounds, a center latitude, center longitude for the station, the identifier, the in-service column, and so on. It's a lot range of stations. You can see how many we have. We have 130 stations and 8 columns in total. Yeah. Okay. So one thing here the interesting part about this data is that there's an obvious index that we want to use. So again, let's see. So Pandas has created an index for us. So here the stations are indexed again starting with 0, 1, 2, 3, 4. But we already have an index column in here, right? So which is the station index of our bike stations. So there's kind of no need. So first of all, this index is different. It starts at 157 rather than 0. And this is already a unique identifier. So there's no point in kind of using a new index in here. It would much more sense to just use the index here, the index that we loaded in here as the index for our Pandas table. And so we can do that. And so the way this works is you call the setIndex function on a data frame, and you pass in the column that you want to have as the index. So if I do that, you can see that now our index has been replaced with the station index. So now indeed we start at 157 and so on. And the second interesting thing is that now actually index, or the ID column here, has disappeared. Right? So because we don't need it anymore, we just moved now this ID column basically to the official data frame index. Otherwise, everything is the same. So also as a note, so what you can't do anymore now is you can't extract the column anymore now with the name ID, because it doesn't exist anymore. Instead, you now have to use stations.index. Right? So if you use station.index, that will give you all the indices of all the stations. Okay, and so now so as always when we plot things, the x-axis will by default will be based on the index. So for example, if I plot the number of logs as a bar plot for all the stations, it will take some time, but again, this is very difficult to read. But here on the bottom here, these are now all the, well, let's, I'm not sure if this helps. Let's just print the top 5. So now here, instead of kind of having these anonymous indices, we now have actually the station index on the x-axis. Yeah. Okay, are there any questions so far? Is all clear? Then let's start again at 1:15.